Hi, and everyone else.
Hi, Luis.
Hello, hello. So a couple more minutes for people to trickle in. We'll take 2 more minutes. We can go from there 1 minute.
How's the weather in Canada, Luis?
It's pretty warm right now. It was a little chilly last week. I think it dropped to Fahrenheit, I think it's like 70. I think right now was the lowest last week, but it's pretty consistent, 78.
Hmm,
Pretty
that's
surprising
good.
for October.
Hmm. Seems pretty pleasant. Slightly warm, I guess.
No, this last 2 years, I'm noticing like I don't know if it's climate change or whatever it is that it's definitely um, not as cold as it used to be.
Hmm. Yeah,
Well, I know the San Fran Bay's got to be always nice, right? So
yeah, it's just about right now.
nice, nice. Do any of you go running in the mornings?
But I guess it's the age I started walking.
Yeah, and I guess that's not love. Once you have like family, kids, work, like lots of kids from out the window. Okay, we'll start right now. We have 13 participants. It's being recorded anyway, so I want to get through today. I do have a hard stop at 9:50. I think it's like 9:50 p.m., so 10 minutes before the hour. So I'll try to get through as much content as I can today. If we can't, well, then we'll have always the next class to finish up. But I'm really excited about this class. And this is something I changed because I was going to go simple through RAG evaluations. But it seems like there's a lot of concentration for class to talk about AI agents evaluations and how do they work. So I definitely customized this class this week to be around this. So hopefully this will be very informative for those who keep asking how to do AI agent evaluations, how do I do this, how do that, versus typically just your RAG evaluations. And I'll be sharing the notebooks after class. And again, the reason why I didn't share with you beforehand is simply because there is a lot of different things, the APIs. I'll talk to you through them, and then you guys can try it after class yourselves, a couple of these things. So we'll just get started. So again, today we'll get deeper dive into how do you evaluate these systems. So imagine they ask you, okay, Satya, I want you to create an AI agent that goes into Jira, pulls information from tickets, and then logs in and do those actions. So how can you create a ground truth to something that has an action? Like if it's saying, I need you to grab this user's Jira ticket and edit it and go back, you can't really develop a golden data set for developing that action. Or you need to look at, did it reason well? Did it call tool this tool well? So like how do you evaluate this? And this is what we're getting into right now. And there's different methods and techniques of looking at especially around agent tractions from there. So first of all, before you even start working and you start developing, you need to find ways to trace your functionalities and your calls. So what's tracing? Tracing is a decorator that you put inside your code that's called traces that will log each interaction that your model's doing. So the reason why you do something like that is because think of it just like how you would put like a timer in your code, right? For example, you would put time from this step to this to execute this one step in Python or script you have. You do the exact same thing, but now with a tracer or a decorator, which you put on top of your code that tracks that task. Then you track the next task, and then you track the next task. All this tracking is called tracing. So you have to put tracing into your code that completes the journey request of the agent. And this records events, state changes, function calls, and values. So any single time you come get and answer things out of that as well gets captured into this tracing. And why would you want something like this? You want something you can debug. You need something to optimize. You need to understand the behavior. So if I'm going to create that Jira ticket, did my model call the right tool function? Did my model call the right ID number? How did it pull the right API number? Did it understand and parse properly back? And did it give back the right solution? So that whole journey needs to be traced. And then if you're not tracing your journey, you don't know your model's messing up. And this is where you'll see a lot of people creating agents that have latency. And we'll go through some of that today because I made some latent agents on purpose. But you'll see that when the model goes and looks and searches for things, it's not always a perfect path. It's not always a happy path. You haven't done strong prompt engineering and doesn't understand what tools are available. You need to go back to your tracing and saying, where did I go wrong? And this is where you come back and you join and you loop and you loop and you loop and you loop and loop again until you finally get something that's better. So the first step is to have tracing enabled into this. So like I was saying before, the benefits is enhanced debugging. You can go in now and say, well, why did my model take so long? Oh, it looks like in step 5, it iterated 3 times to understand this part. And actually it cost me 60,000 tokens because the model kept looping and stuck on that one area. So again, you need to understand like where that part's in. Yes, so very similar to telemetry. Yes, Satya, very good. Again, the whole point of this is transparency and looking at where to look at to do performance optimization. And again, most importantly, again, is compliance. So if you're in a very highly regulated industry, like life sciences, legal, and things like that as well, and you're creating an agent, you need to provide full logs and reason and tracing of how well your agent is doing. Because if you're saying, oh, I'm just going to let this chatbot go, if you're having something that needs to be approved from like the FDA, they're like, well, show us proof why your model's acting this way. Show us proof and justify this way. So unless you can pull out this exact step-by-step process, you're not going to be able to answer those questions. So what are some companies that provide some of this tracing capabilities? Again, I think Aperna put Langfuse, and that's definitely one of them. Microsoft Azure AI Foundry, Filler AI, Ariz AI, Agent Ops, GenTrace, Langsmith. These are different companies that offer this. And we'll go through 2 examples today of Phoenix AI, and we're going to use also Langsmith AI today to walk you through how this tracing looks like and why it's important to sort of have it and how it becomes sort of fused together. So let's say you have you have an agent that needs to respond to two different actions. One, if it needs to go and register someone in a program, and two, it needs to answer directly from an FAQ bank. How do you evaluate this and how do you benchmark that? So again, going back to sort of what the RAG was, you need to create a golden data set. And golden data set is crafted, and we'll talk about that later on in the next slide, but it's crafted from humans. So again, it could be crafted from AI as well, but you definitely want something to be human because it needs to be, at least have a human review because this is going to be your ground truth, and this is where you need to you need to ground the model in something. You can't just say, I'm gonna let the model do whatever it wants, and then if the model looks like it's giving the right answer, like that's not good enough. You need to say, okay, I have a PDF of documents. I know exactly line one. This is the definition of this. So when I ask, what is the definition of this? I'm going to use exactly from that PDF and put that there. So I have my question and my expected answer. Now, when you ask that same question to your LLM, how close is that to the expected answer? And that's where you sort of build your ground truth. And this is where you need to improve. So if you need to change it to be more specific, be more broad, this is where prompt engineering comes in as well. I need you to look at this, look at that. Golden data set is how you evaluate it. And again, I showed an example of TSPY. This is an example of how to develop your golden data sets, but we'll go a little bit more into it in the next part. So how do you define a golden data set? You need to define an evaluation criteria. So think of this as your UAT testing. You need to develop a good testing strategy around how you're going to test your agent and test around FAQs. You need to establish a clear metric, what constitutes a good or correct response. So and again, this needs to be defined on a case-by-case basis. Is your case that the FAQs just needs to pull information from the FAQs and that's it? Does it need to be as close as possible? Does the tone of the LLM need to be changed? This really, again, all depends on your use case. What are you trying to achieve with the LLM? And you need to make those as your metrics and in your judgment. We'll talk about those, how to make those metrics and from there. But you need to stop and think about your strategy. I think on Wednesday I talked about two important things. What really makes or breaks an agent, or really makes or breaks an LLM is one, the data curated for it, so before the data that comes in, and two, your UAT testing strategy. Building agents is fun and it's good, and that's the easy part, but evaluating it and getting the right data in, um, and that's the main difference. So this is where you need to come up with a good test strategy around your AI agents. And you stop by looking at one, what is the business set I'm trying to do? And what is the goal I'm trying to achieve? Once you understand the goals you're trying to achieve, let's say you need to get as close as possible to the PDF and not change anything, you need to create metrics. It's like, is the model concise? Is the model grounded? And then whatever the model responses come in, that's what you're evaluating. Now, if you're building this for another company, if you're building this for another department, you're building for this, as much as you know much as about the PDF, if you're not the SME, you need SME experts to review and provide the ground truth labels and validate their QA responses are right. So as much as you think you know this has to be these type of questions you need to respond, if this isn't your area of expertise and you're building it for another department or you're building for something, you need a SME to be working with you and build that human annotation golden data set. Again, I'll iterate this the most, and this is something I always advocate for when we're doing AI strategy is that you always need experts to review this because if the experts say, hey, yeah, that might make sense, but actually in business this happens and therefore we need this response, you won't know those edge cases. You won't know what really the model should respond. So again, if you're working with someone outside your area of expertise, please bring in a SME to do this, and that's the most important part, that human annotation area. And again, balance and version control. So let's say you're using GPT-4o Mini as your main model, and you want to test out how the questions and answers look like. if you use GPT-5. So you create metrics and say, okay, here's my metrics for GPT-4 mini. Here's my metrics for GPT-5 mini. Did we increase or did we decrease on these metrics? And that is your reason when to move or change different models. Also, if you're changing retrieval strategies, also if you're changing chunking strategies, if you're changing embedding strategies, how do you know what's a good or not good? Again, by running these golden data sets. The only thing I would say you need to watch out for, though, is that if you have over 600 rules, you need to create different variations for each of these rules, right? You need to be testing the happy path, the unhappy path. What happens if someone hits something else? Like you need to create different variations of questions for that one rule. So if you have 600 questions, you do 6 times 5, that's over 3,000 Q&A pairs that you'll have in your golden data set. Now you have, so we'll talk about next about LLM as a judge. When you create these metrics and you're running them on 3,000, this would be over 3,000 LLM calls. And you think about cost as well. So if you're doing 3,000 LLM calls and right now you only have, let's say you're working with a company that only has credits to do a certain amount, you can burn a lot of your credits doing these automated testings. And that's what these are. These are automated tests that you're running through the LLM. You're not running these questions one by one. You'll be developing a script that runs all the questions you want to ask for and then run it on that automated pair. So one thing you have to be very careful for is when you do your UAT strategy, think about costing, think about how many edge cases, and how are you going to be evaluating this, and if it's really well is really important as well. Let's pause here. I see there's some questions in the chat. So how is tracing different than regular method tracing that we use for OpenTelemetry? Here methods are not present to annotate. So maybe you want to expand a little bit on that, your question?
Yeah, like tracing, for example, let's say we have a Java server running and then we want to look at the tracing. We enable some metrics and then the telemetry instrument shows that. Then how different is this from, for example, with AI agents, we don't have those kind of methods exposed to ask to trace, or like how this is different from that?
Yeah, for sure. So example, I'll give you an example of this is like Datadog, right? Let's say you enabled something that has tracing enabled and Datadog gives you, okay, this API post is healthy, this one declined 200, blah, blah, blah. The difference between this one, it actually breaks down what your LLM's agent call is, what tool it chose, why it chose, justifications, and also the next path to go. So I'll give you an example of this as we go on the script, so you can sort of see the difference between tracing and LLM versus tracing and just on APIs or software development pieces.
Gotcha.
Yeah. And to do that, we need to maintain the common Jira login for MCP use case you mentioned. Can OpenAI response be different based on user access to the location? Do we need something with a user specific login too? Looks like there's a companies working on. Yes. So you can do you can when you have your MCP server, you can have authentication based off of user login. So let's say you have everything on Azure AD, right? And your MCP server connects to an Azure database and it pulls information from there. When someone logs in, you can set up authentication tokens that get sent to your MCP server. MCP server will take this authentication token, handshake it with your AD and Microsoft Azure, and constrain it to only the roles that you've created in your AD environment for that user. So you don't have to worry about that user going in and grabbing any other information. You can have that authentication process sort of be built out your MCP. So that's a good question. Can explainable AI be used as part of tracing? Why have it separately? Okay, so explainable AI is another topic, which I'll probably get to the end, but explainable AI walks you through how the model decides how to answer, but we don't need to go to that much detail if we're looking at that as a business case. Right now, your assumption when you do this business, these models have already been vetted from OpenAI, these models have been vetted from these other vendors, and they have good reasoning. When you look at explainable AI, you're taking off the layers off the LLM and trying to understand how did it approach from looking at this prompt to what it's looking for. So we're not going to go that deep into it. What we're trying to do is here's your use case, and did the model work properly on your use case? If not, let's figure out why.
Actually, the reason why I was saying that, Luis, is here's the deal, right? Like, so for example, if you have 15 MCPs, okay, and then like your tool, you gave a prompt to the system, okay, or a prompt is equal to problem, right? System, and then it figured out based on the inputs, like I have to choose, MCP 1, 7, 10, for example, right? Because like it was able to parse it. But of course, the path's different on if the one comes out to be the output from one may lead to you to go to 7 or 10 or 3 or 2 or whatever it is, correct? The ordering, correct? If the parts of it, which is part of the explainable thing, like if it prints out even the basic information, right? Explainable can go to any level of detail, right? Even if you print parts of it, the first part of the explanation, isn't that sufficient for your traceability, is what I was referring to.
Yep, so that's all part of tracing. So you'll see why the model chose 1, 7, and 9. Like a person like requested me to access information. Then you'll see, let me pull the tools. I see that tools 7, 8, 9 are the ones most relevant for me. I'm going to do this. So you could see this all in the tracing. So that could we'll show you a little bit more about that. And I know Praneeth had that same question. Is it only for RAG? As you can see here, this is for any LM evaluation, AI agents, RAGs, anything that tracing is really important.
So Datadog in general, that can have quite a bit of tracing, but it's very high level, isn't it? So if you want to go, like Swami mentioned, you could basically have something like Micrometer or something, which is like very low level, and then have, you know, uh, basically broadcast whatever you want. Can that be a possibility in this particular case? I don't know if you can have that level of detail when you're actually.
Yeah, so usually when I'm on these projects, I have two dashboards. One is the business dashboards and one for IT dashboards. So you can have an IT dashboard that you're saying has the telemetry of, did the API calls work? Did this work? Did the functionalities up or something like that? So you would need to have a separate dashboard just for your telemetry on your APIs and your calls and your MCP server ups. That's one section, but that doesn't help you to break down what's going on in your agent model evaluation. That's not going to help you to understand, like understanding that your API is up is not going to say, why did my model choose MCP server 6 versus MCP server 10? You need
Correct.
you need separate tracing to understand the logic behind this. And this is where this separate tracing is different. And once I start showing you some examples, maybe this will start clicking in for majority to see like, oh, okay, this is what this is.
That sounds good. Thanks.
So now that you have your tracing, how do we go to our metrics? This is where LLM as a judge comes in. So LLM is a judge where a powerful LLM evaluates the output of another AI on a predefined rubric rather than exact string matching. So what this means is, let's say you're using Claude to sort of develop and make your model, and you have it expect answers out. What you're trying to do is tell another LLM to say, hey, is this model response safe? Is it grounded? Is it hallucinating? Is it actually pulling information from the chunk? Yes or no? So a lot of people, again, I think they had the same question on Wednesday saying, well, how can you trust another LLM to evaluate another LLM? Like that seems to be very counterintuitive. But you need to think about this way. LLMs produce hallucinations, produce things when it's generating content. So in the sense that, hey, write me a novel, or hey, write me a 2, 3 paragraph of why Mars is the best thing. The model needs to be creative. It needs to look at a bunch of different things, pull information out. But when you're telling an LLM to look at, hey, look at these words, do you see anything negative in here? Do you see anything not safe in here? Anything grounded? You cut the scope of all of its training to really specifically to be, hey, I'm actually a grader and I'm only looking at specific contrast things. So that all that hallucination, all that risk drops from being really high 60% to maybe 10% or 8% or 5%, because now you're giving us only one specific task to the LLM. And what LLMs are really good at? Reading text. That's their bread and butter. That's what they do. and that's what they're trained on, and trained on especially on BERT models. So when you tell another LM, hey, is there anything unsafe in here? It's not going to hallucinate. It's going to read directly from your document and say, yes, there's something unsafe. I don't like this. This word is an unsafe word. Or this was a completely biased statement that your LM created. This is why you can use LM as a judge as a big majority matrix. Again, you don't have to use LM as a judge. There are other ways. You can do embedding models, etc. But you need to sort of define what your metrics are going to be. Because once you have your logs, once you have understand everything what's happening, you can then create these metrics from this. So again, you're using LLM as a judge because you don't want binary pass and fail metrics. You can check relevance, factual correctness. Is it safe? Is this clarity? Is it actually using all the information from the chunk that it received to answer the question? It is actually typically more reliable. So going back to your UAT testing, you have 3,000 scenarios. You ran it on your LLM. Now what? Are you going to sit there and evaluate 3,000 test cases? And especially because the words can't be one by one, like LLMs have over 1 million types of ways to respond to a question. You can't really write a unit test and say 2 + 2 is equal to 4, so therefore test all my files for 4. You can't do that. You need another metric to evaluate. And this is where LLM as a judge comes and helps fill in that gap. Because now instead of looking for 2 + 2 is 4, did it do the mathematical computation? Did it produce an output that seems factually correct? Is it aligning with 2 + 2? You're looking at evaluating how the model responds to the answer and how the model it comes out as the final answer as well. So this is the main difference when you're evaluating an LLM response. You cannot do binary. It needs to be looking at many different contexts. So how do you implement LLM as a judge? You have to give specific prompting and specific rubrics for each of them. So you just can't say, okay, I want you to evaluate these 3,000 responses. I want you to give me conciseness. I want you to give me grounding. I want you to give me this, blah, 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 and then spit out me a number. You need to create special judges with special prompt engineering, each one in order to create that rubric. So let's say for hallucinations, I start off with your role is a specialized grader, UAT testing grader. Your job now is to look and evaluate if there's anything hallucinating from this LLM's response using the expected answer. And please grade this between 0 to 1 and how confident you are in giving that score. So because now I'm giving it specific role, I'm giving it context, I'm giving it exactly what I'm looking for, the model will now use this and use this as the main job it's to do. So of all the jobs LLMs can do, I'm bringing that scope down. I'm saying only look if this model is hallucinating, if it doesn't have anything related to its other response. So like I said before, LLMs are really good at just reading text. So look at the expected response, look at the model's response and saying, you know what? This model made up a part about Mars, which your expected response doesn't have. I'm giving this a 0.1 fail because it created extra information that was not built into your response. And then you build another LLM judge and saying, I want one that's grounded. How much did the chunk did it use to use for your response? I wanted another LLM as a judge that's safe. Please evaluate if there's anything that's biased, unfair, anything that could be toxic, and say pass or fail, right? So you can give separate roles for these LLM as a judge to start going and start validating. So again, after you do this, you can create an overall score and see how well your model is doing on the evaluations. So again, although you can't look at the 3,000s, you might look at the ones that have failed the LM as a judge, right? So let's say out of 3,000, maybe 5% failed, and that leaves you about 100, 200 cases. That's a little more easier for you now to go through the 100 and 200 cases that failed, and then to go through all 3,000 use cases that you're doing. So again, the human validation at the end will help you drill down and say, actually, why is it failing? This is actually passing. Maybe I'm being too strict on my prompt. So you go back to your engineer and saying, actually, if don't forget about if it has this actually means a pass, right? So you go back, you do iterations to make sure these things. So that's why you can't really just go and say, well, I want to use out of the box LM as a judge and that's it. And a lot of vendors will try to sell you that. That's a lot of, well, we have something that looks really good at your accuracy, that looks at your consistency, and you can use our LM validations. But again, um, when you actually get down to it and you start looking at this, you'll understand slowly that it's impossible to build an evaluator that for every single department, every single business, every single location, because each use case is so different. And you need to sort of specify what you need to be looking for under each metric. So conclusion, agent tracing provides essential visibility into AI behavior. You need to enable this to do some debugging optimization. 2, create golden data sets to establish like that benchmark and get constant evaluation. And 3rd, LM as a judge provides nuanced evaluations beyond traditional metrics. And we're capturing all the different edge cases that LLMs could pull out. So again, as for the bottom part, without a solid evaluation pipeline, you're just shipping features and just hoping for the best to happen. So you need to build strong UAT. And again, before like I'll iterate before, if you want something to be successful, you need to have good data ingestion, clean data going into your model. And 2, you need to have a good UAT strategy. And those are 2 things I always spend the most on when my development, because if you don't have those 2 built in, then you're just building an AI model that's, that famous saying, garbage in, garbage out. Saying is, yes, you could build the best AI framework, but if your data is not there, or you don't know how well it's doing, and you're having this probably public facing, and you have thousands of users using your AI, you're not gonna you need something more reliable than that. So that's the slides for today. Let's start into some notebooks. Just a second. Okay. Sorry about that. My Mac sometimes likes to hide my windows on me behind other windows, and hard to bring it over. Okay, so we're going to be looking at Phoenix to understand one way of doing tracing. Like I said before, I didn't share this one before class again because I made this class very customizable. A lot of people were looking for AI agents, so I spent a little time yesterday trying to build everything from scratch on a couple of things so we can have something to share in class today. So I'll share these notebooks after class so you can have them as well and try through them, and we'll get through this. So Phoenix is, like I said before, another LLM tracer. You sign in phoenix@arise.com and you can have different projects. And in these different projects, here's a demo one that they show is looking at different chains someone's doing. So example, you could see the total of traces. Traces means a total of runs created. You can actually see the total cost of running your LLM in terms of tokens per cost. Your P50, your P90 of how well that latency is doing in terms of time to response. And again, for those who have not seen P50s or P99s, is that you're trying to estimate how long it's going to take you to respond. And this is a metric really famous when you go into production because some people might have strong restrictions. Like, no, I want every response to be under 3 seconds, or else this project is a failure. So how can you show that to your clients, or how can you work that for yourself? Again, by running these P90 tests in which the LM will look for yourself in terms of doing the timing and show you what's the average time to respond to it. And when you get inundated with requests, That's still the average time, right? So that's what the latency metrics are for. Here we also have, I think this one has two really built in: correctness, how many models the responses are correct, how many hallucinated in terms of responses. So you can have a quick dashboard of seeing like your relevance, your precision, your hit rate. So you can quickly see how well your model is doing right at a time. In this dashboard too, you see a line by line of different inputs. So example, if I click on this input here, this is someone's question. Can I use GRP for trace collection? And we see the output of the model of the final response. So you can use GRP for trace. So how did the model get there? So when you click on a name, as you can see here, we see a bunch of the traces that are happening. And this is how the model goes from that one response to the final output. So instead of worrying like how well is my flow working, how's everything looking at that information, at the top we'll start off saying, okay, did it actually work? Yes or no? Yes, it was good. How long did it take to execute this? Well, less than 1 second. So we're able to get a good response. So under 1 second, it did all these different tasks. So when you look at that task, is first it has a retriever. It takes that one question and says, can I use gPRC for trace collections? So the input is from the model that the chat model that you have in. This person said if someone embedded some images, is there anything extra that he added in? No, they only added this text. So what it does is it creates this output. This output gets sent to the next step inside your model, which is your retriever. So now it's going to look at different chunks of metadata based off the retrieval responses that you probably didn't see on the back end, right? Again, you're talking about you talk about telemetrics, you're only looking if it's being able to work or not. But you can see here that it's more than that. You want to see, did the chunks that are being pulled to my model as actually making sense? Do these chunks need to be changed? Looking at like this one, for example, is there a chunk that actually makes no sense? Like, why is it pulling this type of data when I'm asking questions about tracing? Something's completely off with my retrieval. So you need to go back, adjust your retrieval, and adjust it until when you ask that question, the proper chunks are showing up. And you can do that by either editing the metadata, going back and saying, did I actually do the proper chunking strategy? Do I need to change it? Again, this is where you debug and you debug until you actually get a response that's actually right. It goes back to, I think it went back and got uses the embedding model. So we show here that we're using the text embedding to embed this question and gets the query embedding. Now that I got our input documents, it's going to use Cohere re-rank to re-rank your chunks to which one should be the most appropriate response. And again, this is all the flows that you're creating in there. It's how to get the response out and synthesize. So here's the response. Here's the text chunks that could possibly go with it. The model is going to then split out this to be more clear, refine the response, split it out, grab it, give it back to the LLM, and then finally come back with your final answer of, yes, you can use gPRC for tracing collections. So all this steps, all these things happened behind the scenes of you asking simply just one question. And this is an example of a RAG where you have a question and it goes to your embedding, it goes to retrieval, gets re-ranked, gets cleaned up, gets split, and then again back to the LLM, and the LLM responds. So when you look at tracing, this is where you debug and go deeper into understanding why of what's happening. So going back to our slide, this is step one, right? This isn't your end all, but when you start, before you even build your golden data set, before you even start tracing, if you're a developer and you're developing these AI models, this can really give you good visibility of why your RAG is not working properly or why your agent is not calling the proper tools. You go step by step each one, so you can sort of understand what's happening from there. Okay. So let's go back to our Phoenix project. So to create a new project for Phoenix, I'll put the website link for everyone so if you in the chat for those who are curious to use Phoenix. You simply just sign in. You could sign in with Google. You could sign with another place as well. You click New Project, and I'll show you how to create a new project. So I'll tell you how to install the package you need. So someone asked about telemetry. So again, you can use Phoenix OTL or OpenTelemetry to configure your application to send traces to Phoenix. You can use that as well to do this. So also the main key part of all these different tracing vendors is that you need an API key. And these API keys, guess what, are free. They don't cost you anything. These vendors want you to put your information into their systems. So one, they can train on it, and two, you can get used to it and really enjoy the system so that you can upgrade and change it to sort of like the enterprise version, right? Next is you set up your OpenTelemetry and you trace it to the project. It tells you there. You create your project name. You put your endpoint. For me, example, this is because it's me. It's going to say my name, Luis Diaz V1, and you'll see that in the code. But this will change to your name as soon as you do it as well. And if you have any questions how it works on OpenAI agents, Anthropic, Llama Index, LangChain, Light MCPs, etc., and how to integrate it, they definitely have they show you how to create the instrument and how to do the OpenAI examples as well. So they have good documentations and they can walk you through that side as well. If you don't want Python, you can use TypeScript yourself, how to do this, and if you want to change the colors. So, and then you create your new project. So when you create your new project to put your names in here, it automatically here gets logged. So we'll only do the first half of this book. So Phoenix came out with these evaluations maybe, I think, a year ago. And their documentation is really bad. So again, this is why I changed to Langsmith, and we'll do that in the next part. But again, I just want to show you an idea of how to use different vendors and how the tracing looks like across both areas. So in order to start is we're going to install the packages we need for this to run. So I'll just connect to my runtime. And these two might take a little bit to run on this first part, so we'll just wait for it to run. In the meantime, while this is running, I'll do an export of this book and put this in the chat as well. So let me just download Python file. Let me just put this in the chat. Okay, it's in the chat now for those who are wanting to use it. So again, I don't expect you to this time, I don't expect you to follow this one. This one personally works with OpenAI in this example. So for those who are curious how to get API from OpenAI, I was going to walk you quickly through that as well. So OpenAI has something called a playground. So you simply just go to OpenAI, look around. Sometimes it may show up right away as the first tool. Because it's Bing, I think it's maybe this first one. So let me just double check. Okay, let's quickly sign in. 1 second, guys. Let me just get my authenticator. So just like Google Studio, OpenAI has its own playground to work with. So why don't we always use OpenAI's playground versus Google I Studio? Is one, you can't use OpenAI Studio unless you put some money into it. So they put you to put credits into the account, and then from that you're able to get API keys. So this is why I always chose to do Google Studio. Google Studio is always free. You don't have to worry about that. But right now, for you to get an API key from this, you need to click API keys. You need to create your own API keys from there. Once you create your own API key, unless you fund the account, it won't work. So after you create your account, you need to click fund. And after you click fund, you're able to then input a minimum of $5 into the account. And after $5 account, they'll ask you one thing. They'll ask you, hey, if you're willing to share whatever you're working on with us, we'll give you up to 250,000 tokens for free daily. So again, 250,000 tokens is a lot if you're not using this every day. Also, 250,000 tokens, if you're not having anything that's private and you're not worrying about them seeing the data, you can just click share and it gives you that. So you're not spending that $5 ever, or unless you go past the 250,000 responses, then it'll start going into your API credits. But again, if you're using a small model like GPT-5 Mini at 0.0001%, it'll be a little harder for you to do that. Yes, so and I'm not sure if you guys know about the horror stories of AWS and leaving servers on and leaving instances on in AWS. You can definitely get a $20,000 bill into your account simply because you forgot to turn off an instance in AWS. So that's definitely something to watch out for. So again, in this package, we're just installing the Aries Phoenix package for us to connect to it. We're using OpenAI. Again, for this one, I'm going in here. I have put my API key in here, so I'll just enable that for this. And also get my Phoenix API that I got from my Phoenix website. And that's only two things I'm enabling for this project. So import our package is done. We'll make sure the model is able to get this. We're going to be using GPT-5 Mini, which is probably 10 cents more than GPT-4 Mini, but I definitely like how smarter it is. And here's where you name your project. So, for example, talk to your data agent. So when I go back to my Phoenix account, I should see a project that has talk to your data agent on that as well. Yeah, that's a good one too. Fun fact, I was on this project once and I was building my own EC2 instance. It was my first time doing this maybe years ago. And I forgot I left it on. And it was only 2-3 days. It was only 2-3 days I left it on, and I came back and my bill was about $6,000. And then luckily I had to talk to support and say, hey, I'm sorry, this is my first time doing this. I don't want to pay that. And they were lucky to refund me at that time. But it's one of those things that you say that happens to you once and you'll never forget again of doing something like that as well. So we're enabling the Phoenix tracing. So we're just using our Phoenix key that we got. One thing for you to note is that you need to put your own endpoint into this. So when you go to Phoenix, and I said you create that new project, your endpoint should be your project. This is your endpoint, and it should always be the same. So when you go and grab your endpoint from this, you grab it from your new project, and you're putting that into here. So again, if you just run this, all these traces will go to me, or you'll run into an error because your API key won't talk to my environment. So again, just make sure when you run this on yourself that you don't run into those errors. Next, we're just going to register the project. It's going to give me an error because we already registered yesterday, but it's showing that your details are up. Our project Talk to Your Data is up. We're going to use something called span. So span is how these tracers work. It's spanning all around the areas and collecting all the information. Our endpoint that we said we got from our Phoenix area and how we're doing the transport. We have our API key and authorization number, and we're good to go. So we're going to be working here with a data set that's on Google APIs already in there. So that's already installed in it. So you don't have to worry about pulling that data in. All you do is run the storage data cell. And this is the data set we're going to be working on. So again, this is what I talked about is having a good data set. So if you know you're going to be doing, you're building a talk to your data agent, which is building on a table. If this table contains nulls, if it contains spaces, if it's not trimmed properly, inconsistent formatting, things like that, how well do you think your model is going to do when it runs these SQL queries? How long times it's going to iterate on this, right? So again, big thing I say is garbage in, garbage out. Please create clean data for your model for it to understand, because think of it as an intern. And sometimes it has like a PhD level smartness to it. You're like, wow, I'm really impressed. But then it can't do basic arithmetic sometimes. Then it's like there is that inconsistency of like how smart are you? So again, to make sure you check all your bases, always make sure you have clean data that it's able to use in EOS. So in order to create a SQL searching agent, you need to have it be able to generate a SQL generation prompt. So what you want to do is you want your model to generate a SQL in order to extract the information from your table. So in order for it to extract a SQL, you need to create a SQL prompt. So this is the prompt. Generate a SQL query based on a prompt. Do not reply with anything besides the SQL query. The prompt is prompt. So again, we'll see that prompt will be filled in soon. These are the column names available, and this is the table name. So you need to know, you need to give the details to the model saying, hey, I want you to query this data, but these are the table names and these are the column names, so you can understand and know when to call the right column. Generate this definitions of how to create that and add that to our chat template that we talked about before in the other classes of the role, user, content. That chat template needs to now have this SQL generation added to it, because after you get the prompt, it needs to go to the SQL generation prompt. And here we start our first trace. So you can see up here, it's simply just a decorator on your code. All you simply do is add tracer.tool on top of your definition. That means I want the model to look at this as part of my tracing functions. I'm not adding anything added to the code. I'm not building anything out. I'm simply just putting this decorator on top of my function. And the reason why I can do this is because in our imports, we're adding in our Phoenix dataset that makes it really easy to track our tracing functions. And because everything's already pre-coded for us, all we have to do is simply just call that decorator tool to start. And also, if I want someone to look up sales data, implement a sales data lookup from a Parquet file using SQL. This is the table name is sales. If it doesn't exist, then select everything from the stores DF, print the store name. So right now, what I'm trying to do is create definitions of the tools our model's going to use. So one is our database lookup that we're going to tell our agent to look at. So how the tool is run, show me all the sales for 13/20 on November 1st, 2021. So if we did this correctly, an LLM is going to run this prompt and create a SQL that pulls this information out. So when I clicked on this, show me all the stores 3/20 on November 1st, 2020, we're actually getting an input of data, of information of all the sales that are happening that day. So how did this work? How did we know that? So because we put a decorator tool on this, now we can go back to our Phoenix side and find out what's going on. So let me just refresh the page. So our talk to our data agent is now here. And because we used only a tool, we did not use our agent, we see that a tool was called. And we look up our tools, we can see it took 7.94 questions, and more responses for this. And we see the output. But so let's see what happened during the prompt. So input message, generate a SQL based on this prompt. Do not apply to anything else besides the SQL query. That's our prompt is, right? Our system prompt. That was the question that we asked our model. And then it added in the extra information of that. So if you go back to our prompt template, remember the prompt is prompt, so it's injecting here the prompt that we defined, the question that's asked, the columns that are defined, in there, and then also, I think here is also the table name, sales. So here we're looking at how the model is able to then use that to generate a prompt. So from here, the model used this, sent it to GPT-5 Mini, and created a SQL statement. So it said select everything from sales where store number is equal to 1320. So we see here the stores was 1320 that we asked for. And on November 1st, 2021. So it said here, so we look in it and sold date is greater than greater than equal to 2021 November 1st and less than the specific date, right? So to me that looks pretty solid. It's able to look at, okay, it's showing me for only one day and where the store number is equal to 1320. And then when it ran that query, it actually pulled out all the information that we needed on that day. So then it showed us on our evaluation table that it worked. So before I even talk to my agent, I'm verifying the tools that I'm asking it to do. Do the tools even work? So we see this one works, which is great. Next is our data visualization tool. Let's say you want it to not only grab the information, but I want you to create a trend line based off that information. We're talking about something agentic now, right? We're not saying now you don't have to worry about, oh, I'm not giving enough context, I'm not doing something. You can actually now tell it to do multiple actions. So then we also create a data visualization center where we talk about our x-axis, what our chart type is, what our y-axis, what's our title, and then we create another trace for this. I want you to generate a chart visualization containing the data to visualize, and description of the visualization should show, right? And then the dictionary containing the like configuration, so we know a dictionary of what a chart should have. Our prompt is generate a chart configuration based on this data, the data that we'll have. And the goal is to show this. Okay, so Praneeth asked a good question, sort of going back on this page one. So the LLM generated the SQL function. We didn't give it the SQL function. We just told it what table names there were and what headers it had, and the prompt, and then the LLM was able to generate a SQL to do this. And this is why you need to go back and do these evaluations, because sometimes the SQL may not be right. Sometimes the model may not understand all the table names. It might go into an infinite loop and break. You need to go back to your tracing and see how well the tool works. So again, we're just having the different axes from here. So I'm just going to run this because this shows our different traces, how to create charts, how to generate the visualization. And then here's a code. Let's generate an example data on line chart of sales over each day in November. Now in this code, it doesn't have a visualization. So what we should see here is that on our back end, we should at least see the Python code that's needed to generate a visualization. So let's keep it, it's going to run a little bit. This one takes a little bit more time because not only are we going and asking it to get information from SQL, we're asking it to go generate a SQL query, get the information from that SQL query, then give it to our second tool, which then takes that information, maps it to a chart, and write a Python code to generate a line figure based off that information. So right now, Swami, that's a great question. We're just evaluating how to test an agent step-by-step workflow, not the current output evaluations right now. This is simply just step one of the tracing. So let's go back and see how that works. Okay, so it's done. We can see here that it took about 36 seconds. This one took more tokens. This one took about 4,000 tokens to generate. And again, the cost is less than 1 cent to run this. and then we'll see what happened here. So now it's saying generate our information. So we got the table from it, looks at the line chart that we're developing, the date, the values, the titles, and the data. So now that it was able to pull that information in, it completed this section, and then goes to our separate function of create the chart. Now with this data, it goes into building a Python function that says import pandas as PD, import matplotlib as a plot library, and import the string. And here's the raw Python code to develop it, how to run it, aggregate the totals, sort by day, and then plot the line chart. Like I said before, this isn't right now just for visualization tool. There isn't something that can visualize charts right now inside Phoenix. But what we can do is validate, is this Python code work? Does this Python code will generate the image that we're looking for? Will it show, etc.? And that's what we're sort of evaluating on this side. That's a question. What's the difference between tracer tool and tracer chains when you decorate the functions? So a tool is when you're calling one specific tool set that you have, right? So right now we defined one that says your SQL generator. The next one we're defining is a generate visualizations. So we have the tool here of that side. Now, I think you were looking at before was the demo. I think there was something called chains. I think it was there. So the difference between this one is you'll see here as well. The difference between agent and chain is that this chain is doing a chain reaction of pulling a RAG. So you're grabbing one question, you retrieve the information, you chain it together, you're doing a re-ranking, and you're putting it all together at the end, and that's it. So usually RAGs are what you call a chain. And then you'll see here, as we'll get to the ones that we're seeing next on our talk to your data, are agents. And agents are ones that are called multiple tools. So that's the main difference. Next, we're going to run at how the Python code will work in terms of our tracing. The next tool we're going to do is a data analysis. So not only are we going to create a function that pulls SQL data, not only are we going to pull a function that generates a chart, we also wanted to think about the information that's being pulled out and actually analyze it. So let's see how that actually works. So again, we create a definition, analyze our sales data. Implementation of AI-powered sales data analysis, analyze the following data that we got from the first table, and your job is to answer the following question from this prompt. So when we ask what is the most popular product SKU, this is going to be the prompt. The data is what we already pulled from the first file. And let's see how that works. So when I run this and I run this, it's going to run just tool number 3. And we should see tool again on Phoenix because we're not running the agent yet. This is just us testing the different functionalities of our agents. And it's able to ask the question, the most popular SKU is 61905. It was sold 5 units, and the highest quantity sold is in the table. So not if you're asking an LLM model to do this, you won't be able to. It's only able to do only one function at a time. But what we're doing now with our agent is you can ask an agent now, so give me the total sales for this day, plot the line, and give me a report of why it's important. So the model will then hit all these 3 tools. It will create the SQL query, pull the data, create a graph, and our data analysis actually make a report that could say, based off the information, we found this, this, and this, and this, and this, and here's a line graph that we can develop to show this from this part. Yeah, Praneeth, you had a question?
So, Louis, in this case, specifically when you call something as a tool itself is also calling some LLM to do some of its tasks. So the way I understand tool is a Python function where human writes and you pass the output to LLM to refine it. So if tool itself is an LLM call, then you can write everything as a single LLM call and let the LLM decide what it needs to do and generate an output, right? So in this case, why are we creating multiple tools, which each thing is also calling a different LLM calls? So why are we doing that?
So you made a good question. Why are not we just doing one big system and having the whole system work together? And what you'll see is that usually in LLMs models, giving too much data complicates and breaks the system. People are developing and found that tools, in the sense that you can tell an LLM what tools are available and use that to make functional calls. So example, you could have a main orchestrator, which will have a main orchestrator that takes a system prompt and decides which tool to use at that time set. So if you tell an LLM right now, hey, go and get the information, you need to create a new framework, Praneeth. You need to say, okay, I want this LLM to first do this function. Then you would have to chain a next step after that to then create a graph for it. Then you have to chain another data analysis to say, go back and now analyze this. It's a step-by-step features. It's not like I can call my SQL function and then have it to make the line graph and then analyze at the same time with LM. It's going to be it's a lot of steps for one LM that could easily break if one thing is off from it.
Okay, sounds good, Liz. Yeah, so the goal is, let's say if you have a bigger task, you have to split it into smaller chunks and call individual LLMs and then make the work done. And then finally, orchestrator will refine all the entire output and give you an answer. So is that how we should think about it?
Yes, you need to break these into smaller subset tasks, because think of it this way. If one thing breaks, you don't want your whole model to break. Let's say your data analysis tool can't analyze or get the right function out, then your whole function would break and you're not going to able to respond. But if you run an LLM agent orchestrator, it can then iterate on certain tasks, or you can function it, or you can then say, oh, I'm sorry, I got information from task one and task two, and this was the information I was able to pull out, but I couldn't analyze the data because X, Y reasons. Breaking into smaller tasks makes it really easier as a developer to debug and get the most out of your system.
Yeah, I agree from the developer point of view, but isn't this more costly? Because each tool is calling your different LLM call and it will cause more requests and may cost you more things, right?
Well, it only costs you if you are using all three at the same time, right? So again, you're using specific tools. Maybe you ask one question, write me what's the best day of this, right? You're not using the you're not using the image generation tool, nor using the data analysis tool. You're something the element is I'm only going to use tool one, boom, and then you only use tool one to respond. So it's not costing you to go through all of them. Now, if you were to then put tool two and tool three into your context of LM1 that you have and have all the information there, and need to consume 50,000 tokens of context every single time one person asks a question.
Mhm.
Going to consume lots of, because it's going to have to understand it can do all these different tools, but you have to give it all that context, give it all the functionality, have it to read. And meanwhile, you could only say, I only want tool one. It goes to tool one, gets the answer back and come back out, and you don't have to waste context or token windows on the other ones because it doesn't need it. So again, you need to just think about the efficiency, just like MCP servers, right? I need to get information from this database. You can hit MCP server 1, MCP server 3, and number 5. But if you're telling it to look at all the APIs, and then here's all information from all the APIs and get information, you're just burning tokens because you don't need to go through all that flow.
Sounds good. Thanks, Liz.
Okay, so in order to get our router, so again, this is the most important part of this tool, is choosing the router that lets you choose which call sets you have. So example, we have our tools. So we're going to tell the model, hey, this is a function. This is the name of that tool. Here's a description of our tool, the types of objects it has, and the description is the unchanged prop they have. So we're gonna be doing this for all our tools, so that when our LLM, like I said before, it doesn't have to take all the context of everything that we've written up, this whole thing here, of these definitions, things like that. Only thing we'll say is, hey, I have access to look up sales data, in which I know sales data, I can look up sales price elasticity, so I will use only that tool. Or hey, I see I need to analyze the data, so I'll use this function to use that tool. I'm looking at this function, so I'll only use that tool. So we're giving it definitions which tools it can use in order for it to get started. So when our tools are defined, now we have to define the main routing and tool call handling steps of our agent. So this is where we said before, how do we handle and how do we orchestrate an agent to understand that it can just use those tools? So we create a definition for that is handle our tool calls. And you can add them to our append messages. So we simply just add that in. We're going to trace how well, and this is the most important part of to me, this is the most important part of the trace is understanding which tool it's calling and why. And this is where it breaks down the reasoning of, I actually asked it to generate a line graph, but it went to the SQL tool function. Why? That means I must not be putting my right prompts or not generating the right functions of it understanding which one it needs to use. So I said before, how it works is with span, and which will have that spanning running across everything. We're running with our agent, and now we're good to go. Now, this one's going to take over about 5 minutes to run. I tested before because it's not optimized. So we can go and look at how this looks like right here. I think I ran it yesterday. So let's create a line chart showing sales in 2021. So we'll go back to our input. Okay, so this one actually took over a minute on that side. And we can see here the different tools it's going to use. So if I say create a bar chart showing total sales store by store, I should see one. It should call the generate tool function of the tool that we created, and two, a SQL query that's going to give me total sales by store. So I should see two separate tool calls being done and making sure that it's being done and it be given out to me properly. So I could check my router, gets the information, gets the ID. Then we first see the first prompt that it started helping out with and showing which tools we're going to be using. And the first one is create a bar chart showing total sales by store. So it needs to look up the sales data. So we could see here that it calls this tool first. This is the final output, but we're going to get to how it did it. So it goes into our chat template and then creates this function in which it generated select store number, the sum of total sales from sales, and group by store number. So it's able to understand, generate that query for me, and then create me this data from that query that's able to look that information up. Now, as we go back to our second question, we need to create a bar chart from that data. So it goes to the second tool call of generate visualization. Now with this data coming in, creates that data store. We could check the chat completion of how that looks like, and we should see a Python function being made to sort of generate our function to generate our chart, our bar chart. So you can see here the function was created, and then create the plot, and then finally a response back to our final tool call, which would show the Python function because we don't have a Python image enabled for now. So you can see how important it is to look at tracing, be able to understand that once you implement and you run something, you need to look at each one individually. And this is where breaking into different sections is really important and it's really important for debugging. As you can see here that if one of these things could break, one of these sections are not properly done, you can quickly go into your tracing development, see what's happening, patch up the tools, and go from there. Shilpa, you had a question?
Yeah, where does it break down the question into different plans that it has to generate the data, then plot the bar chart with this data?
So sometimes the model does show that reasoning. You can have an extra tool in here that says routing reasoning. You can add that in. But this one, sometimes you just for this one, I think this one here, just shows you which tools it's going to call before it starts working on it. So it's saying here, I want to use this tool call here, one, and it's going to use the next tool call, I believe the other one underneath, lookup sales data function. So this is where, to me, where the model starts planning. I'm saying, okay, I should look at creating how to create a bar chart. I'm using the tool call function of bar charts, and I'm using this to check up the total sales. So right here, this isn't configured to show you the router's reasoning, but you could definitely throw something in there that can add, and you can write a tracer like router reasoning definition. Show me the reasoning of why you chose certain routers, and then that can be part of your tracing function as well.
So that is part of your main prompt, is it? Which says like break down the, I mean, how did you handle that in the Python notebook?
So in the agent right here on handle tool calls, so right here, I'm not telling it to give me a reason or show me the reason why you're choosing the tools. I'm just saying, here's your tools that you're able to use, and add this to your content. So you can see which tool ID you need to use in order to execute your responses. So here I'm not adding in here. I could add example. You could add this and say add and justify, right? We could justify why the reason why. So here we can add extra things in this to understand the reason why if our model is going array.
So basically the LLM handles what tools to call and how to break down your problem as well.
And that's why we call these models agentic, because you're not specifically saying, when you see these use cases, use this. When you see these use cases, use that. We found a lot of research has found that if you were to, sometimes if you restrict the model by giving it too many variations, too little scope, the model does not respond well. The model handles things better when it's able to make its own decisions.
Got it. Yeah.
Okay, so I'm going to jump into the evaluations now because just due to time. Just remember, I'm just going to remind everyone, I said at the beginning of class, I do have a hard stop 10 minutes before the hour. So I want to make sure everyone can get a little bit more of this information in. So next one I'm going to share with you guys is how to do one on Langsmith and on Google. So this is one I built from scratch simply because there's a lot of things on the internet that are outdated. A lot of things on the internet that aren't free. For example, using OpenAI APIs. But if we already have our Google Studio and we already know there's other functions out there, why do we need to go and limit ourselves to this? So again, this is a Gemini and Langsmith functionality. So again, we'll build a multi-turn agent that complex multi-steps. We'll integrate Langsmith to do the tracing for us, export and mine production traces, implement advanced evaluators, and apply best practices for production deployment. So I'll send this again to the end of class to everyone, and everyone will have this. And for you to start working on this, you need to have a .env. This is a sample of how this should look like. So you should have your Google API key that you got from your Google Studio. And the next is your Langsmith. So all you do is, again, I'm not sure if you're able to, let me see here. When you go to Langsmith, on this side, you just sign up or sign up for free. And you'll have pretty much the same thing on Phoenix on this side. And again, you do the same thing. You go and you click get API keys from this, and you're able to then, with the API key and your tracing projects, get the IDs, get exactly what you need from this, and then put this into your environment variables on your side here. So you would get, these stay the same on your environment variables, true, your endpoint here. You simply just put your project name, what you want to name your project, and your .env variable, and you put your API key that you get from Langsmith in here. And that's it. Nothing too fancy. We're just making sure that everything gets traced over to Langsmith, and we have an LLM that we can use. Okay, let me see here. So What's the difference between a simple agent, a production agent, versus an LLM chat that you see on ChatGPT? Is that most LLM calls are single turns with no reasoning. So simple, what's the weather? And you just go and get your response. But we're building something that one has conversation history, can execute tools, and make it complete. So it's very similar to what we see in Cloud Code, where you can add certain tools to the functionality of a UI and go from there. So what we're going to do again is exactly what we did on Phoenix, where we can create an agent that sort of reasons which tools to use, decides what action it's going to do, and then observe the results, and repeats until the task is complete. And this is the main difference, and this is something you'll see on Cloud Code, something you'll see of how these models will then continue until they finally get the right answer. So again, we just install your packages that you need to have before, and we run our setup. So example for me, I'm going to load my environment variables directly from my folder. I have it here, so you need to change it to whatever folder you're saving your .env, whatever environment it is in, and then you simply just click run on this section. So you should see, if you've done everything properly, that your environment was configured successfully. You should see your project name based off your .env. And it tells you you can start viewing the traces that you're building on smith-langsmith.com. So very similar like when Phoenix in terms of getting the projects. Now we're just using Langsmith, which is again another free open source area, and you can do this. Yes, I'll be sharing the notebook at the end of class for this. Well, let's see if I can drag it in. Does it let me drag it in to the Zoom chat now? No, just supposed to have this is the link. Okay. Why multi-turn matters. So show me the sales trend for Q4 2024, and if you find any anomalies, investigate the root causes. So one, this requires multiple turns. It needs to call a tool call. It needs to reason. It needs to detect anomalies. If any anomalies are found, investigate by creating new tool calls and synthesize the findings response. A single turn agent would stop at number 4, right? So an agent will then go back and iterate and get, if any anomalies are found, another SQL call to get more information to understand more. And this is really the difference between doing something agentic versus simply just doing an LLM call saying, understand this. Yes, an LLM can then go and do the whole flow, but a real agent is able to analyze, stop, and say, hey, this is actually something's off. Let's do another query to our tool call again and get more information. So how do we do this? Again, my code is a little bit more cleaner than Phoenix. They're sort of all over the place, but we have an agent state management file where we have our agent states, our agent steps, our agent results. So we have our state of, I want it to think, I want it to tool call, I want it to complete. If there's anything with errors, let me know. Our agent step represents one step in agent execution. So I want you to the action input, any observations, and the final answer. So going back to show your answer, we'll see the reasoning why you decided to do things. And then our final action, what's the answer? What was the steps you got to there? How many turns it took you to get that response? And what was that success? So we simply just run that. So we'll create the same 3 tools that we did before, the SQL query tool, visualization tool, analysis tool. I'm just creating a simulated sales data. So I'm doing from 2024 to 2 months of data. I'm putting some revenue, adding anomaly on day 45, and I'm putting different regions in my data. So again, I'm just simulating something really quickly for this. So similar, just like Phoenix, all we're doing is adding trace decorator to our function. So we're just doing @traceable to this function. And our SQL query tool. And again, here we're adding in information. So all this is prompt engineering, right? What is our SQL query doing? What are we supporting? What's the date ranges? How I want it to be labeled at? How are we going to aggregate information? How we try it from there. And how to do sums, how to do the sum amounts, how to do averages, how to select sales. So again, I want to be as detailed as possible because I want my model to understand what are the best scenarios and best cases for it to extract the data from my data set. So again, this is where, again, context matters, and this is where your context management is. If you know ChatGPTs and Claudes, they have over, I think it's 150,000 in tokens and just simply in prompt engineering, so the model can be very steered and guided properly. So when you create these tool calls and you're giving them all these values, this is a lot of context. And like I think going back to what before, if you put all this different context into your one LLM and it's running all the context from your tools calls, all the context from your third one and your second one, all the context from the third ones, that could easily end up to be over 300,000 tokens and every single call that you'd be calling. So again, this is why it's important to break these down into smaller sections. So then the only context that comes in is saying, hey, this is tool available. Do you want to do it? And if it needs that one, it will then read, and then that will the only cost will be going and activating that one tool that it needs. Here we have our visualization tool. We have our tool analysis tool and how we're putting this together. How we're going to register for the agent. And then we just register as well. So again, here we define our tools. And at the end, we should see that our tools are registered. The model knows that the agent knows that this information is in here now and has access to the analysis, the visualization, and the SQL query. So we want a multi-turn agent with tool calling. So what does this mean? I want it to iterate. If you see something that's wrong, don't just give me the answer. I want you to investigate. If I see something that if you are writing your model and you're running your SQL call and your SQL call fails, don't stop there and say, hey, I got an error. That's what typically LLMs would do. I want you to go back and iterate until you get a SQL function that actually works and that's getting us the information. And this is what you can do with agents. You can do multi-turn agents that have this pattern of reason, act, and observing. And that's what we really want to do. And this is where the agents really get smart because you're giving them now the space of doing this. So here I'm going to do the model. I'm going to use Gemini 2.5 Flash because why? Because it's the one with the least rate limits. We know that sometimes in our Google AI Studio, we get hit into the rate limits error if you use Gemini 2.5 Pro. So we know 2.5 Pro is the smarter model. But how do we know this? I'll show you guys in a second. But Gemini 2.5 Flash has higher rate limits. You can use it whatever it is, and you don't have to worry about hitting it too much. I'm dropping the temperature down to 0.1, so very low. So I don't want it to be too creative. I want it to exactly extract the information that I need, and that's it. Next is we generate tool descriptions for the agent. What are the descriptions for the tools that we have? How do we parse agent response from thought, action, and reason? Trying to change anything here. What's our final response? Normalize the information, check for the final answer. And I want you to look through the different thoughts and actions that we have. So I'm telling it I need to use this format for every response. I want it to use the thought, I want an action, I want the action input. And after receiving the tool results, continue thinking and act until you can provide a final answer and your complete answer too. So remember, break complex tasks into steps, use tools to gather information, and provide thorough final answers. That's what we're sort of setting up our agent to set up what our multi-step agent should be. Okay, so again, this one, I could try to run it now. I think this might be 50 seconds, but it'd be good to see how this looks like. So here I'm running my model. Again, I'm only using Gemini 2.5 Flash for this. I'm doing max iteration of 10. So this is how many times we can tell the model to actually stop and reason through the response I'm looking for. And sometimes you want to do this because what if your model isn't smart enough? What if your model isn't doesn't understand the tool calls that you have? What it'll do is it'll keep iterating, keep iterating, keep iterating, keep iterating till it hits and eats all your context windows, and that one 10 cents call has now turned to a $5 call because you weren't watching the time it took, you weren't watching the iterations, and you didn't put a limit to what's happening. Swami, you had a question?
Yeah, just curious on an example where here to the model, we are telling that, okay, if you are wrong, try again. But we are not giving any additional information in between. So, or could model have tried in the first attempt itself, or what kind of additional data it is getting to correct itself?
Yeah, and that's where exactly the tracing example you need. So one thing I always go for is always trust the models are smart. Let's see and always test them, see how they're sort of guiding themselves. And if you see a model is going way off, maybe it's time to change to a smarter model. These models are should be trained on world stuff. They should be deep analysis. They should have all this world knowledge, and you're simply just telling them to call a simple SQL call. So if your model is not smart enough to understand that I'm giving you all the column headers, I'm giving you all the column data, I'm giving you this, and you don't know how to read a SQL call, maybe it's time for me to switch them to a model that does. So you're trusting and you're giving agentic liberty to these models, and then you're testing and seeing how well these do. So again, this is why doing agents is a little bit more complicated, because you're giving them sort of free reign of how to act. So this model was able to run. We're able to see, we asked the question, analyze Q4 24 sales data. So get the sales trends, check for any anomalies. If any anomalies exist, investigate what caused them and provide recommendations. So we should see at least two calls being hit. One is a SQL data extractor, and two, the anomaly detector, and third, the analysis after it. So next is just prints. And this is just showing me that everything was sort of printed out in action. So the only two things that really are most important are us enabling it and doing our test query. So we're saying that it was able to run successfully. It was able to run, and this did it in 7 turns. And it's able to come back with a final response that says, my Q4 sales trends analysis, the sales data of Q4 24 shows a strong increasing trend, and blah, blah, and different growth this period. Anomalies, no anomalies were detected in Q4 24 sales data. The query is consistent and stable throughout the quarter. Recommendations, continue growth strategies, investigate, blah, blah, blah. So let's see if it gives me a little bit of information. So it walks me through the steps now. So 1, the user wants to analyze Q4 sales data. The first step is retrieve the data for this, and this. Obviously, I can open this in a text editor and read information, but this is where I think the question that Shilpa was asking, so how do we know what it wants to do? This is your reasoning. Your thought is why the LLM thinks that you need to use this tool first. So the thought from it, retrieved from it, was the action was the SQL query. So then it was able to then grab and create a SQL query and get that result. Now the second step is I have the daily sales data for this. Next is to analyze the data. I will use the following tool, analysis. So then it will start reading the analysis. But guess what? There was an error. So although the data was parsed correctly from this area, the way it passed to the tool, and it says error, the JSON object must be string, byte, or binary, not list. Any LLM would stop here and say, that's it, right? Sorry, got an error, cannot analyze. But because we're telling the agent to say, no, I want you to iterate to get the right answer, it stops. Oh, I made a mistake in the previous step. The analysis expects the tool parameter to be a JSON, not this format. So then it tries again and makes another JSON format, but guess what? Got another error, revenue. So then it goes back and says, okay, the tool error returned a revenue, indicating expected column name this for blah, blah, blah. So it needs to then do it again. So it found itself making 2 mistakes, corrected to the 2 mistakes, until it came to a final result in step 4 of analyzing that data. So now that I've successfully performed the trend analysis, which shows this, get this response out, give it to the thought, it failed again, and then it gives it to step 7, and step 7 is able to read this information and then come out with its analysis and thoughts. So you can see how powerful having something that can troubleshoot itself, understand that it messed up, sometimes forgetting that, oh, I guess I didn't tell it, it needs to be JSON every single time in this call. There might be stuff that you forgot to put in as your text. and you quickly go in and you can see what's happening with your LLM. And that way you're evaluating it. And this is where the power of agents come in, and this from here as well. So let's go to Langsmith quickly to see how that looks like on that side. Let me see, let's pull this up. Just refresh the page. Okay, so we can see here as well, you can go back and see how long it took, right? So it took about 1.5 minutes to get the response. This used about 42,000 tokens. So you can see the input was 35,000 tokens. It talks about the reasoning that it was able to go through, how much tokens it was burning. And this is why the output was only 7,208. So when you see these models that are called GPT-5 Reason, or you see these from Claude Reason, and you say, why can I only use, I can use ChatGPT 5, Claude Sonnet 4.5 100 times, but as soon as I enable Reason, I'm only able to use it only 20 questions. Why? Because the reasoning here burns through a lot more tokens to get an answer rather than simply just getting a simple response, right? So here it shows us the total cost of running this one criteria, which is 0.01 cent, to run that one reason. Again, you can go through here, look at how everything is complex, get your output, how analyzed, simply what we saw on that printout stage, what was a SQL call, which model it used, etc., etc. I won't spend a lot more time here because again, we saw this on Phoenix. But this is where you come back and double check if anything is sort of happening, and then you get the results from here. Now that we have our information, and now that we have our traces, what's next? So again, why tracing matters. We checked it. You can see full conversation history, tool calls and results. You can see latency, token usage, and anything with errors. And simply just going to SmithLangchain.com and be able to read it. Now, let's see if we're able to take out the last 3 runs. And boom, we're able to connect to our Langsmith area. My project name is this, so PR fix blah, blah, blah. This is a random name it gave it me. And I wanted to pull the last 3 runs so I can see from it. So why do I need to pull the last 3 runs? Now we're going to start part 2 of let's mine the results that we're getting. So instead of going into that UI, we can then pull what's going on from your tracings and now do some more deeper analysis in this. So we're going to export our production traces and see how that looks like. So we have 10 traces that from our areas that if you connected properly would show the 10 traces that we've done. And then we're going to convert these traces to an evaluation data set. So what we do is we grab those traces and then we're trying to put them into certain tables to be able to read them properly. So when I click run, you're able to see that we're going to put this into proper tables. So how does this look like? Once we put the proper tables, we're pulling in the input data. If there's anything for expected output, it would be in there. But since we're not doing a ground truth RAG, we're just scanning the input from our model, the reference run ID, the source we're getting it from, and the metadata. Now, this is what's important when you go and you present this to an area that requires transparency. How is your model doing? How is your model running? These are the logs that you need to be presenting and giving it to those individuals. Now, let's first check if any of these 10 things that I ran failed. So let's run that function. Guess what? We know all our model runs were successful. We got 100% rate, and the average latency is 3.39 seconds of average latency on the responses. And it found 0 failures, so we are good to go. So now let's do some advanced evaluation of how this works. So like I said before, and making LLM as a judge, we don't have to go in manually extract the responses and pull them out. No, we already have the responses. This is why it's important to have that tracing, and this is why the difference between telemetry and Datadog is that now that we have this information pulled into certain data tables and our inputs, we can start extracting that information and start building LLM as a judge. So the first LLM as a judge that I build out is the hallucination detector. Did the agent make up the data that it wasn't able to pull the data properly, so it just made up some random data? So I want you to determine if the agent makes up information not supported by tool outputs, extract all factual claims from the agent answers, check if each claim is grounded in tool outputs, and flag ungrounded claims as hallucinations. I'm going to use, again, Gemini 2.5 Flash for this. Again, I'm telling my LLM to, hey, and this tool calls, they actually use the information from the tools, from all the 10 things I ran? If not, why not? And again, the prompt solution, you're a fact checker. It analyzes the agent answer contains information not supported by tool outputs. So again, I'm limiting the scope. I'm not telling the LLM to give me a math equation. I'm not telling the LLM to tell me what's Mars. I'm telling analyze these two texts and drill down. So again, this is all for one. All this information again is only for one LLM as a judge. And again, I want this to be in JSON format. So find me the bounds claim, true or false, claim 1, claim 2, what's a grounded claim, and give me an explanation for this, right? So again, I'm telling it all these instructions because I need to understand why it's grounding it that way and why is that responding. The next is correctness. If it was correct, if anything misaligned, so I'm doing the same thing, Gemini 2.5 Flash. I'm saying evaluate this to be proper, how to evaluate it, using the exact same method. Was it using the right tool? Was it really supposed to use the analyze function rather than using the line graph function? Was anything missing, etc.? Next is the reasoning one. I won't get to these ones because it's the same thing. I want to reason. Because this is more reasoning, this is a little bit more subjective. I wanted to sort of give scores now. Was it logically coherent? Was it evidence-based? Was it complete? Was it efficient? What was the strength of the response? What was the weakness? And then give me an explanation. So again, I'm telling the model to give me this rather than just saying, was this accurate? And leave it as that. No, I want you to walk me through it. Was it coherent? Was everything evidence-based? Was it complete? Was the efficiency? What was the strength? What was the weakness? And give me why. So then when I finish my evaluations, I can see that my LLM as a judge is doing really good. And again, finally, output completeness. And this one again, what are the requirements? Did it address the requirements? Was it missing any requirements? Was the detail level insufficient, appropriate, excessive? And give me an explanation. So let's do a multi-turn evaluator because we want this to be a pipeline to run against all this information. So again, we create this pipeline here where we put all the tools that we sort of created ourselves for LLM as a judge. And we want this to run against everything that we sort of have on our log files. So then you define it and you click run comprehensive evaluation. And that's it. That's just that one line. Everything here you see below is just printing the evaluations into more details, into something you can read a little bit more. So you can see here that this took only 1 minute to run on that side. And we're able to then go into here. It's going to start scoring. And here's my evaluation report. So it found that when it ran this model against all the different traces that we have so far in our Langsmith area, it had an overall score of 72%, where it was all thing was successful. And this one only has 7 because we didn't run the extra 3 that we had today. And it was found that 72.5% successful in terms of what it was able to do. So why did you do that? Okay, let's go down to the evaluation breakdown. And it goes down to the LLM as a judge saying, well, it didn't find any hallucination. This includes performance and prevents positive momentum. The agent actually represents this as well normally detected. So again, you're going to go to each of these tools and understand why it gave that score. Correctness, 80%. Did it use anything that's not supposed to be using? Nope, it didn't use anything. So the agent correctly used SQL query to retrieve the data analysis for anomalies. However, visualization is a crystal tool to get to sales trends, check for anomalies, visualizing the data or highlighting it would be highly appropriate and expected for presenting the findings clearly. While a multiple analysis call could be justified for investigating anomalies without seeing the specific arguments, it is hard to definitely label anything as necessary. But the absence of visualization is a clear oversight. Ooh, okay. So it's saying that, you know what, they actually give a good response. But I'm not giving you 100% because you go the extra step. You could have gone, the model could have gone down and created a visualization, then based off that visualization, actually give an appropriate response. So again, you can see here that how LLM as a judge is really necessary in these type of tools because it breaks down all those logs, everything that you're doing, and instead of going one by one checking it, it creates this overall report that you can quickly go in and say, okay, why I'm not getting 100% here, why I'm not getting that, and the LLM will help find you the gaps and help you find those responses. So how do we visualize this and how does this look like? Again, this is just a quick matplot library where you can then see how the different scores for each categories will look like in terms of it being really complete, was a multi-coherent. So again, tool selection was scored 80% because that one comment of saying, hey, you could have used the visualization. But again, I can go back and say, do I really want that behavior? No. So I'll go back to my tool selection prompt LLM as a judge and say, do not penalize if not using all tools because not all tools require visualization. And then I run my LLM again, and you can see that score would then increase, right? So everything is about prompt engineering and getting it right down to the path. So we walk through tracing and we walk through agent evaluations through LLM as a judge. So what's really next? Next is to do A/B testing. So for those who aren't used to do sort of testing in terms of A/B, what you want to do is you want to compare two different agent answers and see if it's actually giving you different versions, different responses, and how to get the overall score. So let's say I want to use Claude Sonnet versus ChatGPT, or I want to use this. How do we handle that? And again, this is through A and B testing, where we create our function to test the different models where here's the queries, here's for agent A, agent B, you evaluate both and see what's happening. So then I'm going to give it agent B to be 2.5 Flash, which we had before. And I want to give it to Gemini 2.5 Pro. And again, I'm willing to spend the extra money because supposedly Gemini 2.5 Pro is supposed to be the smartest reasoning model. And I'm going to test it against these two questions. Show me the total sales by store ID and what was the average price for product ID 101. Once it gets a response, it's going to go use LLM as a judge on both of them, on both of the responses, summarize and get the average score to show me which one is actually the winner for my A/B testing. So when I run this, it took me over 10 minutes and 23 seconds. That burned through a lot of tokens as well. I will show you later. But it goes through, checks the chunkification score until we finally get our final score, which shows that Gemini 8 2.5 Flash scored 67% in terms of choosing the right responses, cohesiveness, and scoreness out of the response. Meanwhile, 2.5 Pro scored a 0.78 score versus that. So we can definitely see on our simple evaluation that Gemini 2.5 does have more reasoning capabilities than Flash with simply just 2 questions from our model score. So if we want to evaluate how that looks like, we can see the average performance on the Flash of how it's doing on the right side, and then we can see performance by query that Gemini Pro beats Gemini Flash in terms of reasoning, coherence, groundness, hallucination on almost every other question. And again, I will share this notebook with you guys. Sorry, I had to run out in 1 minute, but hopefully this gives you a good breakdown of how to really evaluate these models. It's not just enough to look at handful responses. You need to get the tracing, export the tracing, use LLM as a judge, and also look at all these performances and look at these different variables. So hopefully this class was really helpful and really insightful. I'll be sharing with you these books by the end of the day, and send it over to you guys. And I can't wait to talk to you about on Wednesday if you have any more questions, and we can go from there. Thank you, Swami, and I hope you guys have a great Saturday.
Thanks, Luz.
Thank you.
Swati, thanks everyone.
Thank you.
Talk to you Wednesday. Yes, bye. Thanks.
Yeah, there's a lot of information, so don't worry. Wednesday would be the best way to talk more.
Thank you. Bye.
Okay.